Greetings, everybody. Let's go ahead and begin. My name is Brian Rice. I work for AWS. I'm the product marketing manager for RDS, and it's my great honor and privilege to welcome our speakers for our next session here in the Enterprise IT track. Jacques Louvet and Charles-Hammell join us from Comcast. We are so grateful to have them as our customer. They in so many ways make our wired lives possible these days. Jacques is lead infrastructure architect for Comcast, and Charles-Hammell is solutions architect. They're focused on the Comcast X1 platform, which they're going to be telling us more about, and how they've integrated AWS into what they're building. Thank you so much for joining us, and with that, I will turn the show over to Jacques.
Thank you. I started at Comcast about 4 years ago, and before that I was somewhat frustrated with my media entertainment experience. I was playing a lot with Media Streamer and downloading a lot of movies using BitTorrent and trying to find additional content. And I remember clearly one day that I had just finished downloading, spent about 6 hours downloading a movie, extracted it and moved it over to a Western Digital Media Streamer and tried to play it, and played fine, but no audio. Tried a different media streamer, same thing. So I was quite frustrated and called a friend of mine that was working at Comcast, and after I vented, I said, "Are you guys going to do anything about this?" And I was really surprised by his answer, because his answer wasn't really an answer, it was a question. And his question was, "Well, would you like to help us do something about it?" And so, after I signed an NDA, I found out more about it, and eventually signed a dotted line and started working for Comcast on this new X1 platform, which was back then nicknamed Project Excalibur. Comcast had decided to invest in very big and try to innovate. And to do that, they funded a brand new group that would have an extremely high level of autonomy from what we have nicknamed the mothership. So it was almost like a startup. We were hiring almost, 2 people a week in ops for quite some time, until we grew in excess of 300, within a few months. And so we started this project, and, from it came the new X1 platform. When we started, the only thing that we had is a small demo on the laptop. And they started hiring developers, they started hiring ops folks, and we didn't know what this thing was going to look like. We didn't know how many servers it was going to take. We knew basically nothing. And so we decided to gamble a little bit, and take a big guess. And we decided to bet on private cloud. And we started, designing data centers, identify location, connectivity, and buying equipment. And it took us 9 months to basically bring online our first private cloud. But during that time, development needed to continue. And so that's the first time that Amazon came to the rescue. The developers started using instance in EC2 to set up a development environment. And one of my security guy here would say, the mothership frowned quite heavily upon that. They were really scared about putting sensitive information in the cloud. But we did it anyway. We put in a lot of compensating factor, plus also the fact that we were covert. We tried to stay very well under the radar. And that's what allowed us to continue to develop while, we were building this cloud infrastructure. And so what is the X1 platform? Well, the X1 platform for Xfinity, we're all here because we're becoming a connected world. It's no longer, everybody in the new generation has a smartphone, tablet, laptop, desktop, TVs. And so what Comcast tried to do is integrate all these platforms and provide a very rich and featureful experience that is common across all the platforms, so that you can search for a show on your tablet and then play it on your TV, or what I like to do, for example, I like boating, and on weekend I take my tablet with me because Comcast did put some access point at the marina. And the content that I have at home, I can play it on my tablet, on my boat. So instead of me rattling, about all the new features, and now you can use your phone as a remote control and fling content to the screen and do all these fun things, I'm going to play a very quick video, about a minute and a half, that will do a much better job than I could. So with that, back 4 years ago when we started, we talk a lot about the cloud here, but there's something that is a foundation that permits the cloud, and it's connectivity. And when I first started, and I found out that they wanted to put all the smarts from the set-top box into a cloud so that all these systems can play together, I said, how the hell are we going to do this? And very pleasantly, I was able to find out that Comcast invested very, very, very heavily into a backbone, okay? This is a very simplified map, Legal ended up cleaning it up a lot, so. But the one thing I can say is that some of those intercity links are already multi-terabits. So it's a fairly large backbone, it's growing and growing. It's scheduled to quadruple probably in the next 18 months. And so we leverage the backbone that was already there, and all those points that you see on the dot feed what we call CRAN, Comcast Regional Area Network, which feeds a lot of data centers that contain headends and CMTS and the technology that allows the broadband and the video connectivity to the set-top box. And so what we did is that we started building Comcast private cloud, geographically diverse, at various points in the country. And this is where right now our application runs. The first data center I mentioned earlier took about 9 months. That was our main dev and QA site. The next one took about 7, third one 5, and right now we're averaging slightly below 5. We're in the phase of an expansion. And by the first quarter of next year, we're supposed to be adding another data center. But like I said again, we didn't know in the beginning what really the platform was going to look like, how many servers was going to take. And so that's why cloud provides a lot of flexibility. Virtualization, you are very flexible in switching. You want larger instance, you want more smaller instance, you have a lot of flexibility. But still, it was a major guessing game, right? And the budget cycle is once a year. You only have so much money to spend. And we didn't know exactly, how quickly this was going to become, marketable, and how quickly the different markets were going to accept this, because each market inside Comcast has a right to decide when we start deploying this technology into their markets. So a lot of questions and very few answers. And so we need an insurance. And since initially starting EC2, was so beneficial, by then, once the data center came online, first data center, we moved everything in-house and secured it, and we moved all the design artifacts and stuff like that in the initial development, from the cloud. But we decided we wanted to leverage Amazon some more. And luckily for us, Amazon deployed some technology. going a little bit too fast, deployed some technology that would enable us to do that. We knew that there was going to be, an inflection point, at which point, the ramp up and the deployment of these new devices was going to really accelerate. And also, we support about every quarter a hack week, where a lot of the people, not just developers, can propose, something new, and then they get a week to work on it and come up with a presentation. And out of that have come a lot of good ideas that have been incorporated in the product. That, plus a lot of fact that we have a lot of innovators on our team, makes that about once or twice a month I'm getting approached about developing a new service in the cloud. And how many VMs it's going to take, and what database backend is going to require, and does it need to be replicated. So it's constantly moving target. So, sometimes we had enough capacity, and sometimes we did not. And so with all these things, we needed insurance. And that's what we did, is that we leveraged Amazon. Specifically, we created virtual private cloud. Luckily, because of the backbone that you saw earlier, we transited some common data centers, which allowed us to easily establish direct connects between some of our peering routers. And what we did, we used pseudo-wire VPLS tunnels to bring back the traffic back to our private clouds that I presented earlier. And that's the way we have been able to use Amazon resources for elasticity. And, it happens quite frequently that, we want to deploy something else in the cloud, and it's kind of stressing our resource, and then we identify a particular workload that can easily be moved to Amazon. We have all kinds of services running out of Amazon, and Charlie is going to spend a little bit more time specifically on one, a big data problem that we had. And when we looked at it, it looked like actually Amazon had some novel ways to deal with that. And so that's why Charlie is going to focus on this particular workload that we ended up shifting to Amazon. So with this, I'm going to turn it over to Charlie.
Thank you, Jacques. So what Jacques has helped you see so far is how a big, enormous company which owns a lot of network and data center capacity decided and managed to pivot and use something as unique for a company like this as Amazon's public cloud. I want to tell you a story about how we've gone beyond just using Amazon as infrastructure as a service. If all you took away from this as, yeah, I get it, Amazon can be an extension of our data center and give us more capacity, that would be fine. That's excellent, that you need that, and it's so easy to do. But you'd be missing two more benefits I'd like to point out to you with the story I'm going to tell. One of those benefits is to begin to think really differently about software architectures. Cloud computing is not just infrastructure as a service. You get that with VMware. And we've had it for years, and I'm sure many of you do that. It's not a big deal. And it's not fundamentally different. But cloud computing is fundamentally different. And it gives you the opportunity to think very differently about how you deploy software, and if you're in the business of building software, how to build it differently. The second point that you'd be missing out on if all you did is think about infrastructure as a service is some of the unique service capabilities that a cloud offering like AWS gives you. You're here this week, and you're probably hearing a lot about them, and I'm going to tell you in this story about a few that we chose to take advantage of. But what that does for you, once you're in the Amazon world, is an opportunity to quickly take advantage of some services that you understand. You could probably do some of that on your own, but it's so easy to do once you're in the Amazon cloud. So those are two takeaways I hope you get as I tell the story. To reset the stage a little bit, traditional cable TV is actually kind of simple in terms of back-end infrastructure and networking. You're all pretty familiar with the TV experience you've lived with most of your cable lives and maybe still be living with now. And that is there's a thing called a set-top box in your house, and you've got some remote control that interacts with it, It gives you a guide, and you get to make choices about what you watch. It tunes into some channel that's coming in through a cable, and you watch it. And any other additional functionality like DVR, for instance, really happens right there on the box. So a lot is happening on the box, and the box's relationship to anything behind it is pretty minimal. And when it does interact with things beyond it, it's in the form of a regional head end, as we call it. And the head end serves anywhere from a few thousand to maybe, in a really extreme case, 1 million subscribers. And the job of that head end mostly is to deliver a video signal over an RF frequency, and that video signal is in the form of something called QAM. And that's about it. There's a little out-of-band signal that's for networking, and that will occasionally give you a guide update and maybe really occasionally a firmware update for the set-top box. In the case of Comcast legacy systems, that happens maybe every 18 months. So it's actually not a very challenging back-end or networking situation to deal with. Well, as Jacques began to show you, and as you maybe can imagine with the X1 platform, that's radically changed, big time. Because the business goal of X1 is have you more involved with the TV experience, and even to the point of customizing it and the experience kind of learning what you're all about, this old paradigm just won't work. Think of X1 as much more like a complex web application, much more like you're used to with eBay or Facebook or something like that, where there's a lot going on between you and something in the internet. And that brings a bunch of new challenges. And for instance, what we have here is millions of set-top boxes, not just interacting with a regional head end. We've got millions of set-top boxes interacting with the cloud. In our case, it's a private cloud, and I don't mean that term in the same way Jacques was just using it. I mean it in the term of a cloud of services, web services that are necessary to run the TV experience, the entertainment experience that you're getting. So there's all these boxes needing to interact with those services. Thus, you're into the world of distributing that across regional data centers, not so regional, really big parts of the country, and all of those scale challenges, load balancing challenges, and synchronization challenges that any big web application has to face. We've got those problems here. And to do that, you need a pretty massive network infrastructure, which we have, and you have to the big back-end infrastructure as well to manage all of that. Those problems are significant, or those challenges are significant. But one other part of the story is when you are acting like a startup, and I think, by the way, that was a great choice on Comcast's part to treat this like a startup and treat it very autonomously, because I don't think it would have happened any other way. You also get the necessary constraints of a startup. You have to hit certain milestones, you have certain budget constraints, and thus necessarily the X1 platform team made a lot of tough choices early on, and the choices were always in favor of features and functionality over other things, maybe even operational things. One of those things that didn't get a lot of priority is the world of machine data. You may be hearing a lot about that this week because it's a hot topic. Well, these set-top boxes are full-blown Linux operating computers. And there's actually a lot going on them, even though they aren't that smart. There's probably 8 different logging systems on these boxes from different software subsystems that are logging important events. These are very low-level kinds of events that are important to operations, important to the engineers who own the boxes, and also important to even program management and executive level people to kind of correlate issues on the boxes with other trends they're looking at. We didn't give a lot of thought early on to how to get this data out of the boxes and into the back end where we can get at it for analytics. And that was fine for a long time. But a year ago, actually over a year ago, I took a look at that data and projected out what it was going to look like a little later. As of April of last year, the amount of data coming out of these boxes for analytics was about 9.5 gigabytes every other day. I looked at that rate. I looked at our projection for rollout of the X1 set-top boxes, and it was going to look like about 2.5 terabytes every other day by January of this year. And sure enough, that happened, approximately, and we're vastly in excess of that every day now. So multiple terabytes every day coming in from these set-top boxes, that becomes a big data problem. Now, a quick refresher on that handy definition of big data. It's those 3 V's you may have heard about. It can be volume or velocity or variety. Any of those things can make a data problem big and difficult. With set-top box log data that I'm talking about here, the methodology of getting that to us is in the form of what I call log shipping. The boxes package it all up in tar balls and send it over the wire as a file transfer periodically every day now. And so that's a volume problem. And then the data itself presents a variety problem that I'll show you. So how to do that? Well, the solution that was in place for the longest time was rather trivial and kind of primitive. It was millions, or not millions, a few thousand boxes sending files across the wire to a handful of servers waiting to receive the stuff. And then there were some sort of good enough solutions to index this data, make sense of it, and present it for analytics. And while Splunk is fine at handling any scale that you would throw at it, there's a little resistance to that regarding price. So the folks who needed this data decided to go for another solution that you see below. And that solution doesn't scale so well. So this tidal wave of data that I was showing you earlier that was coming at us began to challenge this infrastructure pretty well. And I decided, actually, in one of those hack weeks that Jacques had pointed out back in April, to give this some thought. And I thought of really a fundamentally architected way of getting this data on board, getting it into an analytics world, and delivering it to the people who needed it. And the solution I envisioned was going to eliminate those choke points, and was also going to address cost. Because in looking at the way this previous solution was deployed, in Amazon, by the way, I looked at some of their choices for Amazon infrastructure, for compute infrastructure, and the price tag per month was actually seemed high, and their choice for computing seemed vertical. By that, I mean depending heavily on the compute capacity of the individual instances, solid-state drives, committed IOPS. And that stuff may be really important and valuable in certain situations, but not this one. It just didn't seem right. So I was also concerned about cost, and suspecting that if with a different design and some different choices, we could really bring the cost down and still scale. So the framework that I envisioned way back in April was this. Here we see the millions of boxes coming in and landing the data in S3. And we see it then moving on to a Hadoop tier, and then going back to S3, and then going to a data warehouse, and thus available for business folks to have at it. I'll go into each of these in detail, but I want to remind you what our goals were for this, first of all. It's 3 things. We want to make sure we eliminate any constraints at every tier. Secondly, we want to make sure we eliminate those constraints in an auto-scaling way so that no humans have to be involved in dealing with growing or decreasing scale. And thirdly, we want to do it at the right price. So let's take a look at each of these constraints in a little more detail. First area of no constraints we wanted to create is the manner of ingest, getting the data from the set-top boxes in the scale of eventually tens of millions to a landing zone. What I/O surface is big enough to handle that? And it's not a trickle of clicks on a website. It's not little things going into a shopping cart. It's massive packages of data coming at us. What can handle that? Well, you could imagine a number of ways to do that, I'm sure. Initially, I was thinking, why not something like Flume or Storm? Create a very large cluster of Flume nodes, geo-distribute it, set up GSLBs to distribute the traffic across all the available nodes, and we could solve the problem. And that is, in fact, what we might eventually do. But I didn't think that was ideal for this large package of stuff coming at us. Flume is more ideal for little, small streams of things coming at you. So what happened is, in discussing this with some other folks who cared about the solution, I was shying away from recommending any particular technology choices around vendors, even though I would have happily recommended S3. The person who really mattered here said, why not S3? I said, why not S3? It's perfect. And S3 is indeed an ideal I/O surface for this kind of data. We've done some calculations. We've gone at it pretty deeply with AWS architects about this, and we're confident it's got the I/O capabilities we need. It also steps in and handles the next area of constraint we want to address, and that is a landing zone that's auto-scaling, that's big enough for this amount of data that we have to send. With S3, as you probably know, it's a provisionless environment. You just throw all the stuff you have at it, and you pay for what you take up. You don't have to ask for more. Technically, you don't. Financially, you may. And that's a technicality that really we don't need to mention here because it's not a technical issue. So it solves both problems. It solves the I/O problem, and it solves really the landing zone problem. So we're happy about that choice. Next, we wanted to talk about the matter of what to do with this data when we see it. And this is a snippet of some of the log data, sanitized for your eyes. It has structure, and some people, some big data people would get upset about the idea of unstructured data. They would say there's no such thing as unstructured data. And it's true in this case, this data does have structure to it. But it's not the kind of structure you can point an ETL tool to and say, map it. It just doesn't work that easily. When you get into this kind of data, you're kind of faced with having to parse it. And as soon as you talk about parsing and writing code in Java or whatever, you're talking about another big data problem. Because you just can't write parsers and expect to handle a tidal wave of data efficiently. So that began to imply the kind of processing environment we have to stand up to deal with this data. Now, at this point, I need to pause and talk about the path we're taking through this data and the problem we're trying to solve. This, if you noted in the first slide I showed you about the solution, is talking about a data warehouse destination for this data. And the big use case we're addressing here, I would call a deterministic use case. That means we know the questions we have every day and we want to see the answers. And that's a very important use case and we need to address it. And I believe this way of doing it is the right way of doing it. You'll see as we go along, it's kind of a hybrid of cloud computing, big data solutions intersecting with traditional data warehousing. And it's a common pattern and it works well. But we also have to talk about the other use case that I'm not addressing so much here, and that is, I didn't know I had this question until today, use case. The kind of thing you would use Splunk for a lot. Something's going wrong, and I kind of know what pattern to look for, but I don't know what else is going on in that log. Let me see it. So we have to address that as well. But when I get to this point here, I'm talking about that first use case. So here we have this data problem, and this is a variety problem. That's the other V. So what do we do about that in terms of processing it? Well, as you saw earlier, I was talking about MapReduce and Hadoop being part of the solution. Now, to frame it, I'm showing you S3 again. And over here, we see the S3 landing area where the set-top boxes are sending their data. And our goal is to keep data at rest as much as possible in S3 and spin up compute instances as necessary to do something with it. And this is one of those unique cloud kind of things you can think about differently once you're in the cloud. And it's also kind of uniquely Amazon because S3 is an Amazon service. So we want to take advantage of it. Reason being, S3 is a slightly cheaper place to keep data at rest. You would look at the cost per gigabyte at S3 and compare it with, say, EBS and say, well, EBS is a little cheaper. But before you can use EBS, you have to spin up a compute instance to access it. With S3, you don't. So that's why the argument is slightly in favor of keeping it in S3. We might change our mind about that depending upon our usage patterns of the cluster I'm about to show you. So the next step is to introduce that cluster, and that is a Hadoop cluster. Now, for those of you who don't know Hadoop that well, let me give you a brief 101 on what that is. Hadoop is mainly three things. It's a distributed file system, which is called HDFS. And there's the second part of Hadoop, and probably the main part of it, and that's called MapReduce. And that's the processing environment that allows you to write procedural code that Hadoop picks up as a job and distributes it across a lot of worker nodes available to it to do mapping and then consolidation, reducing into a final output that you determine where it goes. And the third big part of Hadoop is called HBase, which is Hadoop's columnar file store, kind of like a data warehouse sort of solution. We're primarily taking advantage of the MapReduce part of Hadoop here. And another one of those unique things that Amazon offers is called Elastic MapReduce, or EMR. And it's really just the Apache Hadoop distro pre-deployed for you on EC2 instances. It's really an option that you can call for when you're bringing up a cluster of EC2 instances. But the nice thing about it is it's completely managed for you. You don't have to think about the administrative bits, and it makes getting your cluster up and running and bringing it down kind of easy. It also introduces the possibility of scaling your cluster size and even auto-scaling your cluster size. And the way you can do that with the EMR environment is you can introduce a number of different watchers of the cluster or things that launch the cluster to determine what size cluster it should be. CloudWatch can be a factor there. You can have CloudWatch monitoring the cluster, and when certain events trigger your concerns, it can either manually alert you that something is going on, which is a no-no in our world. We don't want that. We want automation. So you can have it also use SNS to send a message to a waiting, simple little script that would therefore react to that and either reduce the cluster size or increase the cluster size. Or you could be deterministic about it and keep history of what kind of cluster size have you needed in the past to get this size data done in this period of time. And that's kind of grow it on your own. You could do that too. But the interesting thing is you can flex the cluster even while it's running or completely shut it down. So our use case here is that we want to operate on a kind of an hourly basis. We want to keep watch on data that's coming in from set-top boxes on an hourly basis, look at the latest stuff that's arrived, and kick off a cluster that's the appropriate size to handle that new load of data and get it done within, let's say, 45 minutes. And that will meet what we think is the SLA of our business users who want to see the latest set-top box data within an hour of its arrival. So let's just say those are the requirements. So we'll spin up a cluster that's the appropriate size to get the job done in 45 minutes. Well, here's another interesting thing you can do when you have an environment like this available to you. We have plenty of Hadoop clusters already in Comcast in our on-premises data centers. And what you can't do with them, and I don't know if you would have this flexibility or not, is I wonder what size cluster it'll take to deal with this day's worth of data or this week's worth of data. Should I guess? Should I do some good math and sort of take an educated guess? Well, with this, exactly what we did is we pointed a small cluster, I think it was maybe 10 nodes, at a day's worth of data. And when the engineer who was doing this test saw that it was going to take maybe like 30 hours to do, he killed it and stopped. Said, that's no good. And he tried like a 30-node cluster, and that got done really fast. It was fast enough. And then he said, I wonder what would happen if I doubled the cluster size. So he threw a 60-node cluster at it, and that got done faster. He said, it's probably too fast. I don't need that. Too expensive. And then he, just for giggles, tried a 120-node cluster, and that got done fast, too. So it kind of scales linearly if everything is right. It's way more subtle and complex than that, but that's just at a high level how it can work. Some of those factors that determine your performance speed are compute instance size, whether it's cluster compute, whether it's solid state storage, whether it's committed IOPS, and all those options that are available to you. But this was pretty simple. So through that trial and error, we were able to determine the right cluster size. And wouldn't that be nice if you're actually planning to do this on premises, to try out your cluster before you buy it? You can do that with this. So we have our Hadoop cluster up and running and getting the job done. Oh, and by the way, the job that it has to do in our case is kind of nasty. It has to unzip these tar balls. And that's really compute intensive. It was necessary to get this big stuff across the wire. And compression is always probably a good idea, but it's hard work for computers to do. MapReduce actually happens to have a library function to do that out of the box. And so it's a good thing to throw a decompression, unzipping type job at MapReduce, and it'll just do it for you very quickly. Then after that is done, we then go through and pull out the nuggets, the dimensions and measures that we care about, and then restage it in S3. Now we're beginning to talk about traditional data warehouse flow here. Consider this side of S3 as the staging area for the data warehouse. The data is now in a form where it's structured. In our case, it's in the form of CSV files, so key value pairs, and an ETL tool, in our case, like Pentaho, can easily map to that. So we'll go there next. So by the way, we can decide to just reduce the cluster size once the job is done, but leave it partially up and running. That's an option, or we could completely kill it. We're going to learn as we go along with this and decide how we want to handle this. So the last area of constraint we wanted to address is around querying this data. So I've already set up the idea that we're staging this data in S3 as structured data now that any ETL tool can deal with. In our case, it's Pentaho, and Pentaho is actually kind of a big data ETL tool in that it scales horizontally. And it also has real-time ETL capabilities. So we've set it up so that it's looking at its buckets, its staging buckets all the time, and as soon as data arrives, it picks it up, pulls it right into the data warehouse. Our data warehouse for the time being is Oracle, and that's got a ton of riches in it that operations people care about. So we're not about to throw that away and say you got to go big data all the way with this. You've got to go to, for instance, Redshift now. I insist on it. It's not necessary yet. We want to add this excellent log file stuff to the repertoire of riches that are already in the data warehouse that's Oracle. It's Exadata, so it scales very well. No challenges there. And it all works. And by the way, getting it then into Oracle or Redshift, you then open up this data to the power tools that business people and analytics people already know how to use. Things like Tableau and Excel. Great stuff. And we're no longer kind of confined to the world of either Splunk, which is a fine tool, but maybe not the greatest tool for BI dashboarding. It's okay, but I think Tableau and Excel are probably better and more comfortable to a lot of people. And certainly not that other tool that I mentioned. It has its constraints. So there we are, all the way through from raw data coming from the wild world of these set-top boxes to a nicely behaved data warehouse environment. There is that other major use case that I mentioned to you, and that is the use case of, oops, I've got a question today because something bad happened that I wasn't expecting. I've got to find out what's going on in my logs. And that is really, frankly, the forte of tools like Splunk to do. But we need to solve that, and we're looking at a number of full-text ad hoc search tools. They range from build our own using a foundation or framework like Solr or Elasticsearch to really full-blown tools that you don't have to build anything, Splunk being one of them, but we're having our reasons for kind of turning slightly away from that. And there's another one coming along that we're taking a hard look at. So we have to solve that, and we're planning on solving it. But we kind of want to limit that tool and that use case to just those unanswered questions and keep this deterministic path the way that it's going here. So that brings us to the end of this little project that I told you about. And I want to review what we've learned from doing it. Remember up front that I said we had 3 goals we wanted to achieve. One, we wanted to remove all constraints at every point we had them and turn any questions about can I have the data into a business decision, not a technical limitation. Secondly, we wanted to make sure all of those constraint points were auto-scaling. We don't want humans to have to get involved and react to choke points. And thirdly, we wanted to address the cost. So how did we do? Well, back in that hack week that I mentioned in April, we prototyped the core of the solution, namely a raw set-top box log file, a Hadoop MapReduce job, looking at some gems in that data and putting it out as a CSV file, and put that together in about 3 days. That was not too big of a deal. Then, with the results of that hack week, including that and some other things, we persuaded some important stakeholders to adopt this as a project. That project got underway, I'm thinking in around May or so. And all along the way, we had some excellent help from solutions architects at Amazon. It wasn't that difficult of stuff, but they just helped us to get going faster. We had people on this project team who were already experienced at Hadoop, but they were not at all aware of AWS at all. And I was kind of the person having to nudge them along into that world. So it took a little bit of ramp up to get used to the idea of a cloud and EMR and what that's all about. But they were up and running quickly. Then the project began, and within about 3 two-week sprints, we had this entire pipeline all the way up to the database running continuously on a portion of production data nonstop. Not too bad. So we proved in doing that, point number 1, we wanted no constraints at every point. And it sure turns out to be the case that S3, Elastic MapReduce, and overall cloud computing and auto-scaling, well, cloud computing, achieved that goal. Then that gets us to the second point. Were we able to achieve auto-scaling? And certainly S3 out of the box auto-scales. That's not hard to understand at all. And there's a number of options of auto-scaling the cluster itself, so we can achieve that. And that's about the only area where we have scale concerns. Oracle is a world of its own, and that's fine. Thirdly, we wanted to deal with cost, remember? I was a little concerned that cost per month of the other system was costing us seemed high. Well, we got this system in place and operational to a point so that we were able to extrapolate what this would cost per million boxes per month. So we were comparing apples and apples. The other system was already designed to handle about 1 million boxes. Wasn't quite doing it. This one, likewise, looks like we know what it would take to handle 1 million boxes per month. Turns out that it's 60% less per month than the other system. So I think we achieved the cost goal as well. So what about you? What can you take away from this? I think there's a couple of things you can take away. First of all, the proposition of Amazon is not necessarily all in. Comcast is certainly not all in with Amazon. You've heard our data center build-out plans, and we're not stopping. But it's an important and really valuable backup plan and really scale plan for us. And it can be for you, too. Especially with VPC, that should make folks concerned about security and access control a little more comfortable. And once they learn a lot more about Amazon security, they can get a lot comfortable. It's really quite good. Getting involved with Amazon, however you choose to do it, whether it's VPC or not, then gives you an opportunity to try out the idea of a really good cloud computing environment before committing to it. And while some of you who are maybe advocates of it get started, you might in the process win over some skeptics who are resistant to this. And I'm sure you have a few of them if you're like any other company. And secondly, once you get in there, you have then access to those advanced features I was mentioning about Amazon that maybe you've wanted to try, but you just don't have the energy to fight the requisitioning battle and the administrative training to get, I don't know, a cloud message bus or a columnar data store or Hadoop or you name it in place. It's off the shelf and ready to go with a click in Amazon. So you can take advantage of that pretty easily, test the waters, and see what you think of it. And thirdly, this gives you a way to decide if and when you want to bring out any of this on premises. Once it's running really effectively in Amazon, I think you'll have the bar set pretty high as to how you would do it if you were to do it on your own. So those are some things you can think about. And with that, I want to bring Jacques back up, and we can talk about some of your questions.